Welcome back to Geometry Classroom. Today we'll talk about surface area of prisms and cylinders. We have two main objectives for this lesson. We identify the solid or the 3D shape or figure and find the surface area of prisms and cylinders. Before getting into details, let's recall a few things about prisms and cylinders. As we know, a prism is a solid or a 3D shape that has two parallel and identical or congruent bases or ends, and the side faces or the faces, the surfaces between these bases are either parallelogram or rectangles. The name of the prism is given by the name of the base. For example, if its base is a triangle, we call that prism triangular prism. If the base is a square, we call that prism square prism or cuboid. If the base is a rectangle, we call that prism rectangular prism. Now, what about a cylinder? A cylinder is a 3D shape that has two circular surfaces, right, that are identical and parallel. In other words, its bases or its ends are circles, and a curved surface between these circles. Now, let's have a few words about surface area. Surface area has two main components. Base area, right, which is the area of the bases, the ends or the top and the bottom. Yes. Depending on the shape of the base, we have different formulas for area. And the second component is called lateral area, is the area of all side faces, or the total, right? The sum of all areas between ends or bases. We have two main cases when we refer to lateral area. Case one is when all faces are the same. So when they are the same or identical, we find the area of one face and then we multiply this area by the number of faces and we get the lateral area. And case two, when the side faces are different. When they are different, we find the area of each face and then you add them. So, surface area is the sum of area of bases and lateral area. So we have a formula for surface area. Surface area would be sum of lateral area plus 2 times base area. Why is 2 times? Because for a prism and cylinder, we have two identical bases, two identical ends. Yes? If you add them, right, you get 2 times b. Now, let's start with the first prism. Probably is the most common prism and the easiest one, right? The first prism is cube, right? As we know, a cube has all its faces congruent, identical, and squares, right? In other words, length, width, and height, right, are the same. To find the surface area of a cube, we find the area of one face, right, one surface, and we multiply by the number of faces. Because there are 6 identical faces, right, the surface area would be 6 times a squared, where a is the side of the length of the side of the cube, right? Good. A surface is 4 times a squared. Why? Because to find the lateral area, we have to exclude the bases, or top and bottom, or ends. And there are 2 such base area. That's why we have 4 times a squared. We have an example. A wooden cube has edges measuring 5 centimeters each. Find the surface area of the cube. Now, to find the surface area of the cube, we apply the formula for surface area of a cube, which is surface area would be 6 times a squared. But in our case, a equals 5 centimeters, right? Yes? So we plug in here, and you're going to have 6 times 5 centimeters squared, which is the same as 6 times 5 centimeters, 5 times centimeters. 6 times 5 equals 30, times 5 is 150, and now the units are square centimeters. Yeah? Remember, the area is measured in squared units. In this case, we have centimeters. That's why we have squared centimeters. What about triangular prism? For a triangular prism, right, surface area is given by this formula. B times H plus L times parentheses A plus B plus C, where, as we can see in both figures, H is the height of the triangle, of the base. B is the base of the triangle, right? Now, because we have 2 such triangles, right, 2 such ends, and they are identical, that's why the area base would be B times H. The second term, L times parentheses A plus B plus C, is the lateral area of the triangular prism, is the sum of areas of faces that are between ends or bases. A, B, and C are the sides of the length of the sides of the triangle, of the base. L is the distance between bases. Good. Let's have an example with finding the surface area of a triangular prism. In this case, right, we apply the formula for surface area. So, surface area equals, first, we find the area of bases, right? We have 2 such bases, right? Now, this triangle, right, as we can see, is a right triangle. this is a right angle. So the area of this triangle would be 3 times 4 over 2, right? But we have two such bases, so we have to multiply this fraction by 2, right? Now, plus L, the distance between bases, is 8, right? Times. Now, we have to add, write in parentheses, the sum of sides of the sides of the base. This side is 5, right? Is the same as this one. So you're going to have 3 plus 4 plus 5. Now, as we can see, these two can divide out. So what's left? Surface area would be 3 times 4 plus 8 times. Now we evaluate the parentheses. 3 plus 4 equals 7, plus 5 is 12. Yes? Now, first we evaluate the first product. 3 times 4 is 12, plus 8 times 12 is 96. Yes? Now, after adding these numbers, we get surface area would be 108. Yes? We have to mention the units would be square centimeters, right? Good. Another type of prism is square prism. What is a square prism? Is a prism whose bases, right, or ends are squares. For a square prism, we have this formula for surface area. 2 times b squared plus 4 times L times b, where b is the side of the square, the base. L is the distance between bases, between ends, right? Lateral area would be 4 times L times b. This is the side surface, right? We have 4 such side faces. Each face is a rectangle. To find the area of a rectangle, we multiply length and width. In this case, length is L, width is b, right? So we have L times b, but you have 4 such rectangles. That's why you have 4 times L times b. Now, let's have an example of a square prism. Now, surface area would be 2 times 9 times 9, right? 9 is the length of the side of the square, plus 4 times L is 13.5, is the distance between top and bottom, times side of the square 9. So surface area would be 2 times 9 is 18, times 9 is 162. 162. Plus 4 times 13.5 is 54 times 9. Yeah? which is equal 162 plus 486. Now surface area would be, if you add these numbers, you have 8, 4, 648, and now the units, square meters. Good? Another type of prism is rectangular prism. For a rectangular prism, right, we have bases, ends in the shape, in the form of a rectangle, right? Remember, the name of the prism is given by the name of the base. Now, for such a prism, we have a formula for surface area. Surface area would be 2 b times h plus 2 times b times w plus 2 times h times w, where b and h are the sides of the base. In other words, the length and the width of the rectangle. W is the distance between bases, right? So let's have an example with finding the surface area of a rectangular prism. For example, in this case, the sides of the base are 3 and 2, which means B, let's say, equals 3 inches, H is 2 inches, and W, which is the distance between bases, is 5 inches, right? So let's plug in here in the formula of surface area. Surface area would be 2 times B is 3 times H is 2 plus 2 times B is 3 times W, which is 5, plus 2 times H is 2 times W is 5. Why all terms are multiplied by 2? Because you have two such identical surfaces, right? In fact, you have two of a kind. Yes? Good. Let's find how much is the sum of these products. 2 times 3 is 6, times 2 is 12, plus 2 times 3 is 6, times 5 is 30, plus 2 times 2 is 4, times 5 is 20. So surface area would be 12 plus 30 is 42, plus 20 is 62. Now units, square inches. Good. We also have a pentagonal prism. Well, I just give you the formula for surface area. We'll not get into many details. So for a pentagonal prism, surface area is 2 times the area of the base, right? The base in this case is a pentagon, right? Plus 5 times A times L, where A is the length of the sides of the pentagon and L is the distance between bases, just for your information. Another type of prism is hexagonal prism. Yeah, hexagonal prism is a prism whose base is a hexagon, right? For surface area, we have 2 times the area of the base, which is the area of the hexagon, plus 6 times A times L, where A is the side of the hexagon, and L is the distance between bases. Why we have 6? Because this is a lateral surface, right? Is the sum of all faces between bases. Because you have 6 sides in a hexagon, you're gonna have 6 side faces, yeah? And they are identical, right? A times L, they have the area, right? We multiply by the number of faces. Good? And the last shape we talk about today is a cylinder. As we know, a cylinder has 2 circular bases, top and bottom, right, the circles, and the surface between bases is a curve, right? So the surface area would be the sum of each such shape, right? And the surface area would be 2 times pi times r squared plus pi times r times h. This is the area of the bases, and this is the lateral area. In fact, pi times r times h is the area of this rectangle, right? 2 times pi times r is the length, and height or width is h. Good. Let's have an example with finding the surface area of a cylinder. Now, in this case, as we can see, r, which is the radius of the base, is 2 meters. H, which is the distance between bases, right, is 3 meters. So, as we know, surface area would be 2 times pi times r squared, right? This is the area of one circle. Because you have 2 such circles, we have to multiply by 2. Plus 2 times pi times r times height. So you plug it in, right? Because we have everything. Surface area would be 2 times pi times r is 2, and we square 2, plus 2 times pi times r is 2, times 3, because h is 3. So surface area would be 2 squared is 4 times 2 is 8 pi, plus 2 times 2 is 4 times 3 is 12 pi. Now we add these terms. They are like terms because both depends on pi. So you're going to have 20 pi, right? If we approximate pi with 3.14, you're going to have 2.8, and now square meters. So that's all we have for today. Thank you for watching my video.